Okay, I'm glad I remember before I got further along. Okay, so we are now recording the lesson. Anyway, so these are the two equations you guys need to know today. Momentum and impulse. Momentum is equal to mass times velocity. Impulse is equal to force multiplied by time. So guys, what I'm going to do, I'm going to start off by doing about like 8 or 9 or so questions from this worksheet. So there are 15 questions total. I'm going to do 8 first, and then after I'm done with those 8, I'm going to come back to this, and then I want to tell you guys what is the relationship between impulse and momentum, because it turns out there's a very real relationship between momentum and impulse, which is what is known as the impulse momentum theorem. So we're gonna do some problems first, and then we're gonna come back to explaining how these two terms relate to one another. Okay, so okay, let us pull up that PDF file that I have in Schoology. Like I said, there are about 15 of these questions. We're gonna do the simple ones first, and then, like I said, we're going to look at the impulse momentum theorem, and then we're going to come back to this. Okay, guys, please fill out the attendance form for those of you guys that are just now coming in. Okay, so let's look at this first question right here. Again, this is going to start off pretty easy. Okay, this first question says, what is the momentum of a 0.2 kilogram steel ball that is rolling at a velocity of 3 meters per second? Super easy. You guys know that momentum is equal to mass times velocity. So if the mass is 0.2 kilograms, the velocity is 3 meters per second. So 0.2 times 3 gives me 0.6 kilograms meters per second. Okay. So that's super easy. Please be sure you recognize your units, because on that assignment, there will be questions where you got to get your units right. Number 2 says, if a ball is rolling at a velocity of 1.5 meters per second and has a momentum of 10 kilograms meters per second, calculate the mass of the ball. Well, so let's just plug everything into our equation. We know our momentum is 10. That's what they told us. So momentum is mass times velocity. So momentum is 10. We're trying to find the mass, and they tell us our velocity is 1.5. Okay. So guys, y'all know how to solve this for mass. In order to get mass by itself, you're just going to divide. So 10 divided by 1.5 is going to give you your object's mass. Okay. In this case, the mass, if you put 10 divided by 1.5 in your calculator, you should get 6.67 kilograms. So that is the object's mass in number 2. Okay, so super easy. Okay, let's just keep going. Determine the velocity of an object that has a mass of 2.5 kilograms and a momentum of 1,000 kilograms meters per second. So again, if momentum is equal to mass times velocity, we know our momentum is 1,000. We know our mass is 2.5. Okay. You guys know how to solve this equation for velocity. You just divide. So 1,000 divided by 2.5. Turns out that gives me a velocity of 400 meters per second. Okay. So that is the equation. That is the answer for this question here. Notice my units. I'm using my units for velocity, meters per second. Now let's keep going. What is the momentum of a 100 kilogram fullback that has a velocity of 3.5 meters per second? So momentum is equal to 100 times 3.5, right? Because it's mass times velocity. When you do that, that gives you 350 kilograms meters per second. So that's the magnitude of my momentum here. Okay. All right. Now, going on, let's look at some impulse questions now. Number 5 says, calculate the impulse of a 5 Newton force acting for 4 seconds. Remember what I said what impulse is. Impulse is force multiplied by some time interval. Change in time is just a time interval. So force, so impulse is equal to force multiplied by some time interval. So, so 5 multiplied by 4 seconds, that's obviously 20. And notice my units, 20 Newton seconds is the magnitude of my impulse. Okay, super easy. Number 6 says, if the impulse is 35 Newton seconds and it lasts for 3 seconds, what is the value of the force? So if you plug in 35 for your impulse, and it says your force lasts for 3 seconds, y'all should be able to solve this for the magnitude of your force. Basically, it's 35 divided by 3 gives you your force. What is 35 divided by 3? It's 11.67 newtons. Okay, so notice my unit. Since I'm solving for force, I'm just using newtons. Okay. Number 7, if the force of an impulse of 30 kilograms meters per second is 6 seconds, how long does the impulse last? So they tell us, by the way, guys, one of the things I want to say here, even though they tell us it's the value of the impulse, notice what they did here in terms of their units. They gave us the units for momentum. Now, technically, you are allowed to do that. And the reason why you're allowed to do that is because there's a direct relationship between impulse and momentum. And we're going to see in a moment what that relationship is. It turns out the two can be equated to one another. In a moment, we're going to see why that is. So even though you are allowed to use the units for momentum for your units for impulse, typically when we talk about impulse, our units are Newton seconds. But again, it's technically not wrong to use these units for impulse. And in just a moment, we're going to see why. But anyway, so they tell us that our impulse here is 30. So I'm going to plug in 30 into this equation for impulse. It's equal to, it says the force is 6 newtons. So we're trying to figure out how long is the impulse lasting. In other words, we're solving for the time interval. So you can easily solve this equation because 30 divided by 6 gives you delta t. What is 30 divided by 6? That is clearly 5 seconds for our time. Okay. Look at number 8. Number 8 says calculate the impulse of 10 newtons of force acting for 2 seconds. Super easy. Impulse is equal to force multiplied by time, which is equal to 20 Newton seconds for our impulse. So usually when we write down the units for impulse, we write it in terms of Newton seconds, and we tend to use kilograms meters per second for the units for momentum. But again, you can use those units interchangeably because there's a direct relationship between impulse and momentum. And in just a moment, I want to prove this to you guys. I want to show you guys why it is we can say that there's a direct relationship between momentum and impulse. I want to prove to you guys right now what is known as the momentum impulse theorem. Okay. So we're going to come back to those questions in just a moment, but I want to be sure everybody understands this. What is known as the impulse momentum theorem. Now, the impulse momentum theorem says that an object's impulse can be directly equated to an object's change in momentum. Here's how I want to prove that to you guys. In order to derive this relationship or derive this equation, I want to start with a well-known equation that you guys are already familiar with, and that equation is Newton's second law. Okay. In the chat box, can someone tell me what Newton's second law is? Force is equal to what? I expect y'all to know this like this. What is Newton's second law? Everyone. Yes, thank you, Nelly. Force equals mass times acceleration. Guys, if y'all don't remember any equation from my class, do remember this equation. Well, Isaiah, 9.8 is the acceleration of gravity. I'm not necessarily talking about the acceleration of gravity here. I'm just talking about any object that's experiencing a force that has an acceleration. You can quantify that acceleration by this equation. So this is Newton's second law. Okay, so I'm gonna start off with this law here to prove to you guys that impulse and momentum can be equated to one another. In order to do that, one of the things I need to do, I need to take this equation here, and I need to change its form just a little bit, You guys see this acceleration right here? You guys should know what acceleration equals to. Acceleration is defined as an object's change in velocity divided by change in time, right? Because that's what acceleration means. Either speeding up or slowing down. Your velocity is changing over time. So I'm going to rewrite this equation to look like this. Force equals mass times change in velocity divided by change in time, where it's understood that change in velocity divided by change in time is equal to acceleration, right? Because that's what acceleration is. It's a change in an object's velocity, okay? So now that I rewrote this equation into another form, let me ask you guys a question. What would I need to do to get this delta t over to the other side of the equal sign? In other words, how do I get rid of it on the right-hand side of the equal sign? Can someone tell me? If I wanted to get rid of this delta t, how would I do that? If I wanted to get rid of that delta t on the right-hand side of the equal sign, what would I do? Yep, multiply. Yeah, you want to multiply both sides by delta t. Exactly. So that's exactly what I'm looking for. So if you multiply this side by delta t, it should be obvious to you all that that goes away. Remember, whatever you do to one side, you have to do to the other. And you're left with this equation here. I want you guys to notice carefully what I just wrote down on the screen. Look closely at the left-hand side and the right-hand side. F times delta t. What did I say? What do we call that? F times delta t. We call that impulse. Exactly. So physicists call this impulse. Look at the right-hand side of this equation. Mass times delta V. Can't draw mine right. What does this right-hand side remind you of? What is the product of mass and velocity? What do we call that? Momentum. Thank you, Neely. Yeah, so you guys may know the product of mass and velocity is momentum. So in other words, guys, mass times change in velocity would be equal to change in momentum. I'll write it down. Change in momentum. So guys, this equation right here proves to you all that there's a direct relationship between impulse and momentum. In other words, guys, here's what this equation is saying. This equation is saying anytime you apply an impulse to any object, you will change that object's momentum. That is what this equation means. And again, I'm proving to you guys how I arrived at this principle by starting off with a well-known equation, which is Newton's second law. So all I did was I just start off with Newton's second law, did a little bit of algebraic manipulation, and out popped what is known as the impulse momentum theorem. So in other words, guys, all this equation is saying is if you have an object and you apply a force over a period of time on that object, then that object will experience a change in momentum. And those two things can be numerically related to one another. So impulse equates to the object's change in momentum. Okay, so with that said, let us look at, go back to our assignment here. Let us finish the rest of these questions. We want to go all the way to 15. So look at number 9. Number 9 says an 8-kilogram object starts at rest. It is then pushed by a 15 Newton force for 8 seconds. Calculate the impulse acting on it. Okay, this is easy here. What is the impulse acting on the object? Well, we know what impulse is. Impulse is force, in this case, which is 15, multiplied by time, or the time interval, which is, in this case, is 8. So 15 times 8 is equal to, 15 times 8 is equal to 120 Newton seconds. Let me make sure I said it right. 15, yeah. So 120 Newton seconds. Okay. So that's our answer for number 8, for number 9. So as long as we know the force and we know the time, we can easily calculate the impulse. Now look at number 10. Number 10 says calculate the change in momentum for number 9. What is this object's change in momentum? Y'all, this is super easy. Remember what I just told you guys. If you know the impulse acting on the object, then you know how much the object will change its momentum. So if the impulse was 120 Newton seconds, guess what? The change in momentum will be 120 kilograms meters per second. Okay? Because the two are numerically equal to each other. If you know one, you know the other. Make sense? So when it says calculate the change of momentum in number 9, since we calculated the impulse in number 9, we were easily able to calculate the change in momentum. Okay, super easy. Okay. Number 11. A 12 Newton force pushes on an object for 4 seconds. How much momentum did it gain? Okay, so guys, in other words, when it's asking how much momentum did it gain, it's asking us what was its change in momentum. In order to calculate change in momentum, we need to know the object's mass and the object's change in velocity. Okay. However, look at what they give us. They don't give us mass, neither do they give us any velocity values. They only give us force and time. So they only give us enough information to calculate impulse. Right? So impulse is force multiplied by time. So if I take 12 and multiply it by 4, what I get 48 Newton seconds. But notice the question didn't ask me for impulse. It asked me how much momentum did it gain. In other words, it's asking for a change in momentum. According to the theorem, if I know the impulse is 48 Newton seconds, then I know the change in momentum must be 48 kilograms meters per second. So how much momentum did it gain? It gained 48 kilograms meters per second. That's how much momentum did it gain, because the two are numerically equal to one another. Okay. All right, guys, let us do these last few problems on the back, and then we're going to call it a day. Number 12 says a 10-kilogram object is initially moving at 6 meters per second to the right. 11.5 Newton force then pushes to the left on the object for 2 seconds. Calculate the impulse acting on the object. So we already know that impulse is equal to force multiplied by some time interval. So the force here is 11.5. The time interval is 2 seconds. Okay. And we're asked to calculate the impulse. So 11.5 times 2, turns out that gives me 23 Newton seconds. However, that's not all, because I want you guys to notice something here. It says the object was initially moving to the right, but the force that was acting on the object was acting toward the left. So in other words, the force is acting against the object, which means this impulse better be negative. Y'all see that? Guys, yes, just like you can have negative momentum and negative change in momentum, you can have a negative impulse. Impulse is a vector. Direction matters, right? So since the force was acting toward the left on an object that was initially moving toward the right, obviously this force is going to slow this object down. So we say that a negative impulse has been applied toward the object because this impulse is changing its momentum. It's causing it to slow down. So it's a negative impulse. Number 13 says an object has a mass of 2 kilograms. It was initially moving at 25 meters per second before a force acting on it and slowed it down to 10 meters per second. What was the magnitude of the impulse acting on the object? Okay. Well, guys, in order to calculate impulse, we need force and time. However, they don't give us force and time. But look at what they do give us. They do give us enough information to calculate change in momentum. And you guys know what change in momentum is. It's mass times change in velocity. So mass times change in velocity will tell us our object's momentum. And guys, let me remind you, anytime you're finding delta V change, you always do final minus initial. So you want to do the final velocity first and then minus the initial velocity, always. So it's important that you guys get that right. Okay, so guys, let's plug everything in. So our mass is 2 kilograms. Okay. So notice it says the object was initially moving at 25 meters per second before a force acted on it and slowed it down to 10 meters per second. So 10 meters per second was the object's final velocity, and 25 meters per second was its initial velocity. So in this case, you get 2 times negative 15, right? Because 10 minus 25 is negative 15. So your direction matters. It's important that your signs are correct. What is 2 times negative 15? Well, that is negative 30 kilograms meters per second. Okay. So guys, this object had a change in momentum that was negative 30 kilograms meters per second. But the question asks, what is the magnitude of the impulse acting on the object? Guys, let us go back to our theorem. If you know the object's change in momentum, then you know the value of the impulse. So that means this impulse here is negative 30 Newton seconds. Okay, so that's our answer for number 13. Make sense? All right. Number 14. A 30 kilogram object is at rest. A 50 Newton force pulls to the right on the object for 7 seconds. Find the impulse. So we can easily find impulse because remember, impulse is just force multiplied by some time interval. So in this case, it's 50 newtons divided by 7 seconds. So guys, on some of these problems, they're going to give you extra information. So for example, they told you the mass was 30 kilograms. And they ask you to find the impulse. As long as they give you force and time, you can easily find impulse, irrespective of what they give you for the mass. Okay, so as long as you know force and time, you have all the information to find impulse. So force in this case is 50 multiplied by 7 gives me 350 Newton seconds for my impulse. Lastly, number 15 says an object experiences a 30 Newton force acting over a period of 5 seconds. What was the overall change in momentum of the object over this period of time? Okay. Well, so in order to calculate change in momentum, we need mass and change in velocity. However, they don't give us any sort of change in velocities, or they don't give us, any values for the mass. They do give us force and time. So force multiplied by time tells us impulse. Okay, which in this case, 30 multiplied by 5 gives me 150 Newton seconds. But guys, if I know my object's impulse, if I know the impulse acting on the object, then I know the change in momentum of the object according to this theorem. So if my impulse was 150 Newton seconds, my change in momentum better be 150 kilograms meters per second. Okay, so that is my answer for number 15. Okay. Any questions? Any questions? Nia, you didn't make it to campus today? Nia, you there?
Yes, sir. I'm here. I'm up here, but we were making stuff for the seniors this year, so I just made sure I logged on.
Okay, so in other words, you couldn't come see me. Okay, I feel okay. I'm not gonna take it personal, but okay, I got you. I got you.
I'm on here, and that's what matters.
Okay. Way to make me feel better. No, I'm just. But no, you're good. All right,
Thank you.
Have a good one.
You too.
Someone sent me a private message. They wanted to know the email address to the lady who's over the AP courses. Her name is Mrs. McClure. I'm gonna put her email address in the chat box for you. Let me do that now. So her name is Mrs. McClure. Yeah, she is over the AP department. So if you guys can just send her in, she's the AP coordinator. So you guys, hey, what's going on, Elijah? What's going on, man? Hey, what's going on, brother? What you up to? Not much, my business. Hey, yeah, give me just a second. I'm getting ready to let them off call. What is the name of the attendance lady? I don't know what the attendance lady name is, Jaden. I don't know about that one. Yeah, you have to look that one up. All right, so guys, any final questions for me? You know what? Let me go ahead. Oh, while it's on my mind, let me go ahead and open an assignment right now in Schoology.
Oh, Mr. Taylor?
Yes?
Tuesday night, there was like a sign-on error for my Blackboard. So I'm not my Blackboard, my Schoology. So I wasn't able to turn in Tuesday night's assignment that day. But can I still turn it in?
Yes, you can.
Okay, thank you.
You're welcome. All right, any other questions, guys? Yeah, Miss Blewett. That's right. That sounds about right. Thank you. See, look at you. Y'all really good at helping each other out. I like that. Y'all are a good group of kids. Y'all are a great group of kids. I wish y'all were on campus where I can just see y'all faces. All right. Any final questions for me? All right. If there are no final questions, guys, remember the Zoom call is going to stay open up to 3 o'clock. Well, around 3:20ish. Um, if there are no immediate questions at the moment, you guys are free to go. Enjoy the rest of your day, everyone. Bye, guys.